Hello and welcome to this Any Excuse for a Chemistry Experiment video. Today we're going to be looking at topic 6 on the AQA syllabus. We're going to be looking at rates of reaction. Hopefully you've got your revision guides. Don't worry if you haven't, use another one or go onto the internet to support the learning that we're going to do here. Today we're going to be covering 3 videos. Each video is going to be taking us step by step through topic 6. We're going to start off with rates of reaction. We're going to look at changing rates in the second video, and in the third video we're going to be looking at reversible reactions and something called Le Chatelier's principle. So in this video we're going to look at 3 aspects. We're going to look at measuring a reaction, working out the rate of that reaction, and looking at some graph work for that reaction. When we measure a rate of reaction, what we're doing is we're actually looking at one of 2 things that takes place. We've got reactants and we're making products. So let's have a look at how we measure any chemical reaction. So we've either got our reactants that we can look at or our products. Let's have a look at the reactants. What is going to happen to them is that the reactants are going to get used up as the reaction goes by. Or we could look at the products, and as a reaction takes place, the products will be formed. So there we go, 2 ways that we can measure the reaction taking place of any chemical reaction that we can find. So the next thing that we need to know is about measuring the rate of a chemical reaction. Now rate is actually a mathematical term. Rate is equal to one thing happening divided by time. So what we need to do is we need to work out what is that one thing that is happening. Well, we know that we've got one of 2 things that could happen. Either rate is equal to reactants used up divided by time taken, or rate is equal to products formed divided by time taken. So we know that reactants go to products, we know that the reactants are going to get used up, and we know that the products are going to get formed. We know that if we want to measure the rate of these things happen, rate is equal to reactants being used up divided by the time, or rate is equal to the products formed divided by time. So our units are going to be one of 2 things. If our reactants or our products are going to be measured in grams or mass, it's going to be grams divided by time taken in seconds, so grams per second. However, if our reaction is producing a gas, then we want to measure that gas, so it will be centimetres cubed per second. There we go. The units of rate are likely to be grams per second or centimetres cubed per second. So the last bit that we need to do is we need to look at the graphs that we're going to be able to draw or interpret in our exam. So let's take, for instance, the reactants being used up divided by the time taken. So we know that when we start a reaction, we have all reactants and very little else. Now the reaction will happen very quickly. If we've got lots of reactants, then our rate of reaction is going to be quickly. So what we would find is that the amount of reactants is going to drop really quickly. But then as we run out of those reactants, there are less around to react with. So our reaction will actually begin to slow down. So what we do is we find that we end up with an ever decreasing curve. But the last thing that will happen is eventually the reactants will all get used up and there won't be any more left. So that graph is actually going to hit 0. So let's have a look at the other example. Products formed by time taken in seconds. Now we know in a chemical reaction at the start we don't have any of the products, so our graph is actually going to start off at 0, our origin. Just like the reactants being used up, the products being formed is going to happen really quickly, so we will have this really steep line. But then what happens is as the reactants begin to get used up, the amount of products being formed at the same time begins to slow down. But eventually what will end up happening is that we will have no more products formed because all of the reactants have been used up. So our graph will then flatten off. So one more thing that we need to do with our graphs is we need to be able to manipulate the graph. We need to be able to find out the rate of a reaction at any point. Now remember, rate was 1 over time. Well, that's going to be quite challenging for us. However, if we have a look at our graph, so this is the amount of product that's being formed over time, we can actually find the rate at any individual point if we wanted to. The way that we do that is by drawing a tangent. So let's take this arbitrary point here. In your exam, you'll be asked for a specific time. And what we want to do is we want to draw a tangent on that line. So we're going to find it where the ruler, straight line, matches the line of best fit underneath our cross, our plot. And then what we would do is we would draw in a tangent line. Now, the gradient of that tangent is equal to our rate. So the gradient is equal to the rate. Now, I'm sure you can remember for your maths, but just in case you can't, what we'll do is we'll work out what the gradient is. So we want to know 2 pieces of information from our tangent. Because remember, our gradient is equal to a change in y over a change in x. So our change in y, so here's our y-axis, so our change in y would be that value. Our change in x, this is our x-axis, so our change in x would be that value. So y, x, and so what we would do is we would look at the scale there, work out what that value is, look at that scale, what that value there, so we'd have our y over x gives us our gradient. And it also then gives us our opportunity to look at the units. So our product formed is our y, so that could be centimetres cubed, and time in seconds divided by seconds, and there you go, that is one of our units, centimetres cubed per second. So there we have it, measuring the rate of reaction. We've looked at what a reaction is and how we would measure the units of that reaction. We looked at plotting graphs from data from a chemical reaction, and then we looked at measuring the rate, either by using the equation 1 over t or by working out the tangent. Thank you for viewing this Any Excuse for a Chemistry Experiment video on rates of reaction. Check out the other 2 as they come out. Thank you very much. Look forward to seeing you next time. Keep safe and goodbye.